Okay, let's take a look at sections 5.3 and 5.4. That's on polynomials and polynomial functions and actually multiplying some binomials. We're going to start out with just looking at some definitions so that you can develop an understanding of some of these because they're going to be pretty important later on. The first is a term. So when we're talking about a term, that's a single number or a product. A single number or a product of a number and one or more variables. So when we look at this, 2a to the third by to the fourth is a term. And then 3a squared by to the third is a different term. So they are separate terms. When we look at something like 2a to the third by to the fourth, that's one term. Multiplication is okay, but as soon as you add addition or subtraction, then you go from one term to two terms. The degree is the sum of the powers of the variables in a term. So when I look at this, I have a to the third, b to the first, y to the fourth. So the degree of this polynomial is equal to 3 plus 1 plus 4, which is 8. The degree of a polynomial is the highest degree of the terms of the polynomial. So when I look at this polynomial, I have 3 terms. The degree of the first term is 9. The degree of the second term is 7. The degree of the last term is 6. Therefore, the degree of the polynomial is 9. Now, a polynomial is defined to be this a sub n raised to the x to the n plus, remember all those dots, those 3 dots mean that that's all the terms in between. And this takes you all the way down to a sub 0 x to the 0, and we don't write the x to the 0 there. Remember, a monomial is a polynomial with only one term. A binomial is a polynomial that has 2 terms, and a trinomial is a polynomial with 3 terms. We're going to take a look at those perfect square trinomials later on. And that's how I'll refer to them. So you need to recognize a perfect square trinomial. Coefficients are the numbers preceding the variable in each term. So for example, the coefficient here is 4. The coefficient here is 2. The coefficient here is 3. This is a constant. And I think we're going to see that on the next page. This is also written in standard form, and I'm not sure I addressed that in the notes. I should. Standard form means that it decreases on the power of the exponent. So standard form is a decreasing power on the exponent, or a decreasing power from left to right. Let's say it that way, and I'll give you an example. So if I have, for example, 5x to the third plus 4x squared plus x plus 9. That's in standard form. Versus if I give you 2x plus 5x to the fourth plus 3x squared minus 6x to the third plus 3, that is not in standard form. So you'd want to rewrite that and put that in standard form, which means it would go 5x to the fourth minus 6x to the third plus 3x squared plus 2x plus 3. That's how you'd rewrite that and put it in standard form. The leading coefficient is the coefficient of the first term of a polynomial written in standard form. So you want to make sure your polynomial is written in standard form, and then your leading coefficient will be the number attached to that first leading variable. The constant is a number that's not attached to a variable. We mentioned that on the last page. So 4 in this case is the constant. The constant term is a term that with real numbers only, no variables. In evaluating polynomials, and this is an important one, you're going to see this formula many times. And it's the formula for the height of an object. And it is modeled by this h of t. T stands for time. H of t means the height over time. So h of t is equal to negative 16t squared plus v sub 0, that's the velocity, times time, plus s sub 0, which is actually the starting height. So you can think of this as the starting height of the object. And this v sub 0 is the velocity. And this object is tossed straight into the air. So A says find the height of a ball tossed straight upward at 64 feet per second. So that's going to be our velocity. From an initial height of 4 feet, that's our s sub 0, our starting height. So the height of this ball after 2 seconds is going to be h of 2 is equal to minus 16 times 2 squared plus 64 times 2 plus my initial starting height of 4. So you can put that in your calculator and find that height would be 68 feet at 2 seconds. Then it asks after how many seconds will the height of the ball be 0. So h of 0 is equal to minus 16 t squared plus 64t plus 4. So h of 0 means that height is 0. And you have minus 16t squared plus 64t plus 4. And we actually can probably factor that. We'll factor out the minus 4 so that we have t squared minus 16t plus 1. I'm not sure that's factorable. I think I'll go to the quadratic formula on that. After how many seconds will it be at 0? Actually, for this one, since we haven't factored yet, let's put it in the calculator. Minus 16x squared plus 64x plus 1. Then when you look at it on the graph, you'll see that it crosses at 4. So at 4 seconds, so when t is equal to 4, here's what it looks like. That ball will cross the x-axis. It says what is the maximum height of the ball. I think we calculated that earlier. It's 68 feet is the maximum height of the ball. And you can find that by taking minus b over 2a. This gives you the x coordinate the vertex. There's the vertex. Okay, so I'm going to put in minus b, so minus 64 over 2 times minus 16, which is a, which gives me my x-coordinate of 2. When I substitute the 2 in, I get that 68 feet. And we'll do several of those over the course of this chapter. We're also going to add and subtract polynomials. There is both a horizontal method for subtracting and a vertical method. You can do whichever you choose. I'm going to show you both. So for problem A, I have 2x to the third plus 3x minus 3x squared minus x plus 4. What you have to remember horizontally is to distribute that negative sign to each of those terms that follow, and then combine like terms and put it in standard form. So I have 2x to the third minus 3x squared plus 2x plus 4. And that would be my answer. If I'm adding or subtracting using the vertical method, I just line up the two polynomials and I line up the powers in columns. So I have x to the third here, x squared here, x to the first here, and my constant here. Now remember, if you're subtracting, you're going to have to distribute that negative sign to each of those terms. In this case, we're actually asked to add. So I'm going to get 9x to the third plus 3x squared minus 9x minus 1. If that were subtraction, let's just take a look at that. So you can see if that were subtraction and you were using this vertical method, what that would look like. Okay, so if that's subtraction, in order to change it to addition, I have to change all of these signs inside, and then I can change that to addition. So now, when I add these together, I get minus x plus 7x squared minus 9x minus 5. Okay? Either method, whichever one works best for you or you feel more comfortable with. I don't ask you to do them specifically. Multiplication of polynomials, we're going to start out just looking at some of these are pretty easy. This should just be a refresh from Algebra 1. So I'm going to take first a monomial times a binomial. So that's just the distributive property, 2x squared plus 8x. Then a monomial times a trinomial. Again, I'm just distributing that. So I'm going to get 6x to the third plus 4x squared plus 12x. Remember, you're multiplying like bases. You're going to add those exponents. Now I'm going to take a binomial times a trinomial. So I'm going to take the first term times each of the terms in the trinomial. And then I'm going to take the second term and multiply each term in that trinomial. And then I'll combine like terms. So I get 2x times x squared is going to give me 2x to the third. 2x times 2x is going to give me 4x squared. 2x times 3 gives me 6x. Now I'll move over to the second term. 3 times x squared is going to give me 3x squared. 3 times 2x is going to give me plus 6x. And then 3 times 3 is 9. Then you just want to combine like terms. So you have 2x to the third plus 7x squared plus 12x plus 9. The ever-famous FOIL method, first, outer, inner, last. Don't forget, you're going to get some that you're going to look at and you're going to forget to FOIL. And that's not going to be right. So FOIL, that's first, x times x is x squared. Outer, x times minus 4 is minus 4x. Inner, 3 times x. And last, 3 times negative 4, which is 12. If you FOIL and you do it in this particular sequence, the middle terms can always be combined. And here we're going to get x squared minus x minus 12. For the next one, same thing. First, outer, inner, last. Going to get 2x squared minus 4x plus 3x minus 6. Again, that sequence generates those middle terms in a way that they're very easy to see how to combine them. Now we have a couple of special rules that it will really help you to remember, not just with FOILing, but also with factoring, because when you can recognize the square of a sum, or the square of a difference, or the difference of two squares, it's going to be very useful. The square of a sum generates what's called a perfect square trinomial. And it will be good if you can recognize a perfect square trinomial. Remember, x plus 3 raised to the second power is not x squared plus 9. This is what I'm talking about. You have to FOIL x plus 3 times x plus 3. It's going to give me x squared plus 3x plus 3x plus 9. You're going to get 2 times that middle term. That middle term is going to repeat, giving me x squared plus 6x plus 9, which is a perfect square trinomial. Next one, 2x plus 5 squared is that 2x plus 5, and you're going to FOIL that, so you're going to get 4x squared plus 10x plus 10x plus 25. You get that middle term repeated, so 4x squared plus 20x plus 25 is the solution. Here's the rule. Will be very helpful for you to recognize that. In the interest of time, please notice the square of the difference is essentially the same thing, x minus 3 times x minus 3. First gives me x squared minus 3x plus 9, which gives me x squared minus 6x plus 9. Only difference there is that middle term is subtraction, and you'll see that rule applies. The product of a sum or difference, sum and a difference, which means that my binomial's the same with the exception that one's the sum and one's the difference. Now, when I FOIL these, I get first x squared. I'm going to get then minus 3x plus 3x minus 9. So what happens to those middle terms is they cancel, and then my answer is x squared minus 9. That's another important one to remember when it comes to factoring. Number 2, I'm going to get 4x squared minus 12x plus 12x minus 36. Again, those middle terms cancel, giving me 4x squared minus 36. Another important rule to recognize. Now, when we look at the cube of a binomial, if I had a plus b times a plus b times a plus b, to get the cube of a binomial, I'll take the first 2 and I'll FOIL those, giving me a squared plus 2ab plus b squared. And then I would multiply a plus b, and that's going to give me a to the third plus 2a squared b plus ab squared. Then I do b, which would give me a squared b, then plus 2ab squared plus b to the third. Then I need to combine like terms. That's going to give me a to the third plus 2a squared b. Then I should have, no, 3, sorry, I missed that one. 3a squared b, then plus 3ab squared plus b to the third. Okay, so when you look at those, this is the rule, and I generated that simply by multiplying a plus b times a plus b times a plus b. So now what I want you to do for Tuesday when you come back is multiply this x plus 3 to the fourth. That's your only other homework. Finish the work from today, do the note packet, have a nice weekend, enjoy your Thanksgiving holiday, and I will see you Tuesday.